Imagine entering into a contract for a home purchase. You sit at a table, surrounded by lawyers, real estate agents, and notaries, each ensuring that the terms are adhered to and that the deal goes smoothly. Now picture a different scenario, a digital agreement, a smart contract that executes itself without any intermediaries. It's as if the home sale were governed by an invisible code, automatically transferring ownership once conditions are met. This is the essence of smart contracts, self-executing agreements where the terms are directly encoded in software. But what does this really mean for how we understand contracts? Smart contracts automate agreements through code. They live on the blockchain, a decentralized ledger that records every transaction transparently and immutably. In contrast to traditional contracts, which are often layered with legal jargon and reliant on human oversight, smart contracts strip away the complexity. They are straightforward. If A happens, then B occurs. This simplicity is both their power and their challenge. Consider the ramifications of removing the intermediary. In traditional contracts, trust is placed in the individuals involved and the institutions that back them. If something goes wrong, you often find yourself in a court of law, navigating a maze of legal recourse. With smart contracts, the execution is guaranteed by the code itself. No third party is necessary to enforce compliance, and this has the potential to reduce costs and increase efficiency. However, it also raises critical questions about trust. What if the code contains an error? What happens when the unforeseen occurs? The strange consequence of this trust in code is that it places a burden on the creators of smart contracts. If the terms of the contract are not thoroughly vetted, or if they are coded incorrectly, the results can be catastrophic. Unlike a traditional contract, where you might negotiate or amend terms, a smart contract will execute as programmed, even if the conditions lead to an unintended outcome. This is where transparency becomes vital. To fully embrace the potential of smart contracts, we must grapple with their implications. Who is responsible if a smart contract fails? How do we navigate a world where trust is placed not in people, but in lines of code? The shift from human oversight to automated execution is not merely a technical innovation, it's a fundamental change in how we perceive agreements and trust. As we explore these questions, we begin to understand that the game is indeed changing. What happens when a smart contract fails? Imagine a scenario where you've invested your savings into a decentralized finance application, lured by promises of high returns. You've done your homework, read the white paper, and even checked the project's reputation online. Yet, one fateful morning, you wake up to find the application has vanished, your funds gone as if they had never existed. This isn't just a tale of misfortune, it raises an essential question about code and trust. Can we trace the failure back to the very lines of code that were meant to execute the agreement? This is where the importance of verifying smart contracts comes into play. Verification is the process of examining the smart contract code to ensure it functions as intended. It's akin to an architect scrutinizing blueprints before construction begins. If the blueprints are flawed, the building will inevitably crumble. In the world of smart contracts, verification can be your safeguard against unforeseen consequences. So how do users go about verifying these contracts? One method is by examining the code itself, which is often available publicly on blockchains. This transparency allows anyone with the necessary skills to analyze the contract's logic and identify potential vulnerabilities. Imagine having the ability to peek under the hood of a car before buying it. You'd want to ensure all the parts are functioning correctly, right? Similarly, reviewing smart contract code can reveal how funds are managed, what conditions trigger execution, and whether there are any hidden risks. However, this process isn't foolproof. Take the infamous case of the DAO hack in 2016. A poorly verified smart contract was exploited, leading to the loss of millions. This incident serves as a stark reminder of the consequences when verification falls short. The DAO had a transparent codebase, but even with visibility, the complexity of its code led to vulnerabilities that were overlooked. On the flip side, consider the success of Ethereum-based projects like Uniswap. The developers conducted rigorous audits and community scrutiny, which helped maintain trust and security. Their transparency not only bolstered user confidence, but also fostered a robust ecosystem where users felt empowered to engage without fear of catastrophic losses. The strange consequence of this is that while transparency can build trust, it can also expose weaknesses. What if a smart contract is transparent, but the code is too complex for the average user to understand? This leads to a paradox. where users must choose between blind trust in developers and the daunting task of deciphering intricate code. So, what does this mean for the future of smart contracts? As we continue to explore these questions, we must consider the balance between complexity and transparency. Each instance of verification, whether it leads to success or failure, shapes our understanding of trust in this emerging digital landscape. It's not just about whether the contract works, it's about who holds the power to validate its integrity. What changes when we take the premise of verification seriously? The stakes are high, and the answers could redefine our relationship with technology and trust in the digital age. What if a smart contract is only partially decentralized? Imagine a situation where you're about to engage with a decentralized finance platform, and you notice that while the code is open for anyone to inspect, a single entity still maintains control over crucial components like the governance mechanisms or key updates. This raises an intriguing question: who truly holds the power in this scenario? The murky waters of partial decentralization can lead to a peculiar balance of trust and control. On one hand, the transparency of the code allows users to scrutinize its functionality, but on the other, the centralized control can introduce vulnerabilities and potential manipulation. You might trust the code itself, but what happens when the entity behind it is not fully accountable to the community? This is where the nuances of decentralization come into play. Imagine two contrasting smart contracts. One is fully decentralized, distributed across countless nodes with no single point of failure, while the other, though transparent, relies on a central authority for critical decisions. The fully decentralized contract is like a community garden, where every member has a stake in its upkeep and can voice concerns about its direction. In contrast, the partially centralized contract resembles a corporate farm, where decisions are made by a board, regardless of the farmer's preferences. While the garden thrives on collective input, the corporate farm risks alienating those who depend on it. Now, consider the implications for trust. In a fully decentralized system, trust is distributed among the participants, fostering a sense of shared responsibility. Users are empowered, knowing that no single entity can dictate the terms or manipulate outcomes. However, in a partially centralized system, trust may hinge on the reputation and integrity of that controlling entity. If that entity falters or acts in self-interest, the entire system can become compromised, leading to disillusionment and loss of user confidence. What strange consequences arise when we take this premise seriously? A user may feel secure in the knowledge that they can review the code of a partially decentralized contract, yet their trust in its operation is tethered to the whims of its overseer. This duality presents a precarious trade-off. Transparency does not equate to trustworthiness if the power dynamics are skewed. As we explore these thought experiments, we must ask ourselves, how do we navigate the complex interplay of decentralization and trust? What frameworks can we devise to ensure that partial control does not erode the very foundation of trust that decentralized technologies seek to build? The answers to these questions may redefine our relationship with smart contracts and the systems that govern them. Imagine a world where your interactions with technology are governed not by the whims of corporations or the biases of intermediaries, but by the immutable logic of code. This is the promise of smart contracts, where agreements are executed automatically without the need for trust in a third party. But as these contracts proliferate, a pressing question emerges. How will our relationship with technology change when transparency and decentralization become the norm? Picture yourself entering into a smart contract for a loan. You read the code and it all seems straightforward. But as you dive deeper, you realize that understanding the intricacies of that code is akin to deciphering a complex legal document, one that is written in a language few can fully grasp. This paradox of transparency becomes evident. The very feature designed to foster trust may inadvertently breed confusion. For users, this complexity can lead to a precarious relationship with technology. They must navigate a landscape where trust is not just a given, it's a choice laden with uncertainty. What happens when the code is too complicated for the average person to understand? Do we end up placing our faith in the developers who may themselves be operating in a gray area of accountability? The implications are profound. Developers face the daunting task of creating systems that are both transparent and user-friendly. They must balance the intricacies of code with the necessity of clarity. Imagine a scenario where a developer designs a smart contract that is technically sound, but so complex that users cannot ascertain its true functionality. In this case, transparency becomes a double-edged sword. While the code is available for all to see, the average user may be left feeling powerless, unable to verify if their interests are protected. This brings us to another critical point. Who benefits from this transparency? Is it the user who seeks assurance, or the developer who showcases their technical prowess? As we ponder these dynamics, we must also consider the challenges posed by decentralization. In a fully decentralized system, the responsibility for trust shifts to the community. But what if the community is divided? What if different factions interpret the code in conflicting ways? The strange consequence is that the very decentralization intended to empower users could result in fragmentation and disputes, undermining the trust that smart contracts were designed to establish. Now, let's envision a future where smart contracts are ubiquitous. In such a scenario, would we find ourselves relying on a select few experts to interpret the code for us? If so, have we truly decentralized trust, or merely shifted it to a new set of gatekeepers? The balance between transparency and decentralization is not merely theoretical. It has real-world implications for how we engage with technology. Users may find themselves caught in a web of complexities, while developers grapple with the weight of their creations. As we draw our thoughts together, we must ask, what trade-offs are we willing to accept? Can we forge a path that embraces the benefits of transparency and decentralization while mitigating their potential pitfalls? The answers may very well shape the future of our relationship with technology, urging us to rethink what trust means in a world increasingly defined by code. As smart contracts continue to evolve, so too must our understanding of the landscape they create, prompting us to reconsider who holds the reins of trust in this digital age.